So, Alessandra, I think we can start accepting people.
Okay.
Hello, we will be waiting for another 2 or 3 minutes that we are sure everyone joins. Thank you, Eugene. So I think we can start. Alexandra?
Yes.
Okay, thank you. Hi, I would like to welcome everyone to our 4th webinar within the scope of SAM project. As you may already know, SAM is an EU-funded project with the target of developing a sector skill strategy in additive manufacturing. Additive manufacturing, or more commonly known as 3D printing, is one of the key enabling industries for sustainable economic growth that is being widely used in a wide range of industrial applications, and AM is a growing means to produce both prototypes and products as well. I would like to give you some figures. The average annual growth rate of worldwide revenues produced by all products and services over the past 32 years of additive manufacturing is 26.1%, where the growth within the last 4 years from 2017 to 2020 is more than 20%. The Wohlers report states that the total AM industry achieved a size of $12.7 billion by the end of 2020. And according to Lux research from Boston, USA, the value of additive manufacturing parts is to rise at a 15% compound annual growth rate from 12 billion to $51 billion in 2030. As a result of such high-speed growth, the demand for qualified labor force in AM has been an urgent necessity. Eventually called on the SAM project to bring in a solution with the objectives of building a sector skill strategy, assessing and anticipating skill gaps and shortages in AM, designing or redesigning professional profiles according to the industry requirements. In today's talk, we have 3 guests that will share with us their educational background and the path that lead them to having a career in additive manufacturing, the difficulties they encountered while moving forward, as well as their advices and recommendations to our audience about building a career in AM. So I would like to invite our 2 speakers to open their cameras to say hi to our audience, and then I will start one by one introducing them. Okay.
Hello, everyone.
Hello, so we have 3 speakers today. These are Ade Sataya from Brunel University, and then we will have Anke Kaletsch from Aachen, RWTH Aachen, and then our last speaker will be Aydın from EOS. So let's start with our first guest. Our first guest is, as I mentioned, Ade Sataya from Brunel University in London. Ade is a chartered engineer and researcher with more than 20 academic publications based in UK. His technical expertise includes data science and analysis, data visualization, statistical analysis, manufacturing processes, mechanical testing and materials characterization, computer-aided design, and finite element analysis. So Ade, if you are online, can you turn on your camera?
Hello, everyone. Good morning.
Yeah. Oh, yeah, we see you. Hi.
Thank you very much, Kenan. And do you mind if I share my screen now then?
Yeah, but I think as Alexandra should stop. Oh, yeah, now it's okay. You can share your screen and go on with your presentation. You're welcome.
Okay. Perfect. I believe you all can see my screen now.
Yes, it's working.
Oh, perfect. So once again, thank you very much, Kenan, for the excellent introduction. And today, and thanks to everyone joining. Today, I'll be giving an insight into my engineering and AM journey, and hopefully include some top tips that will help everyone here. So I'm Dr. Adiayo Shotayo, and I'm a recent chartered engineer based at Brunel University. So the outline today is I'll give a quick intro about myself, then talk about my experience in AM. I'll then go on to some of the positive aspects and challenges and opportunities in AM. Then I'll finish up with some advice and top tips. At the end of the session, there's going to be like a panel session where you can ask some of your questions. So who is talking? Here's an image of who I am. Ignore what you see on the webcam today, but that's how I actually look. And a bit of background about myself. I actually did a mechanical engineering degree at University of Liverpool, UK, where I finished with the first class degree. And afterwards, I didn't go the traditional route. So I actually skipped a master's degree and then went straight to a PhD in engineering, still in the UK at Lancaster University. Then afterwards, I then went to my alma mater. So I went back to Liverpool, where I did a research position in materials and structure. So I worked on developing new materials, testing them, and optimizing new materials. And more recently, I came to Brunel, where my focus is on additive manufacturing, and which I'll talk a bit more about shortly. So a bit about where I am. So I'm at Brunel. Unfortunately, I've not been to campus in over a year now, but here's how it looks. It's a beautiful campus, and it's actually a top 400 university globally, located in West London, and currently ranked ninth for research intensity in the UK. Okay, so now let's move on to some of my experience in additive manufacturing. So firstly, the actual official title of my role is Research Fellow in Additive Manufacturing Skills. And let me give you a bit of context about that. So currently, there's actually a lack of enough skilled AM professionals. That's what led to the formation of my current project. So how we're working on that is we have series of like workshops and surveys and research to try and identify those skills required in AM in the currently and in the future. So this is where I come. I do like a lot of like data management, reporting of findings, and more recently, I actually contributed towards like the 2021 European AM strategy roadmap. So that's one of the ways to try and target this occurring problem of lack of enough skilled AM professionals. I'll talk a bit more about that shortly. And as part of this current role as well, I develop like different training materials and to try and foster knowledge transfer in AM. So we do things like pilot courses. So last year I was part of a team that organized a course on like metals and alloys, and more in the next month we'll be doing one on AM polymers. So we try and develop courses in additive manufacturing to try and educate and upskill people to become professionals in AM. And one of the major goals of my current role is to develop this international additive manufacturing qualification system, which will be right at the end of this project. We should be able to have this system. So if you have any more questions, you can always check out the websites. But this is what some of the things I'm currently working on. So another aspect of my current role is raising awareness. So, and how does that happen? First of all, as a researcher, you do a lot of literature review. You check out what's out there, what's going on, and what are scientists and researchers publishing in the field of AM. So I must say that AM is constantly growing, and there's always new technology that is being developed. So we try and review literature to see what's out there. Based on my materials and mechanical testing background, I try to design experiments to understand or to characterize some of these AM materials. And the aim for this is to try and increase the understanding of these AM properties. And not only just understand their properties, to try and see the future application. So if on my screen you can see a screenshot of one of my recent publications where which was co-authored with Giselle and Eugene Pei, where we actually developed and tested this AM material and where it's being applied for the fashion or textile industry. So AM, we try and continuously look out for where these new materials can be, where AM materials can be applied across different sectors. So that's another aspect of my role. Moving on, apart from that, there's a lot of AM workshops and presentations. So as part of my current project, we do things from like raising awareness to like from school children from about 13s to industry experts. So these two photos were taken pre-pandemic, and where I actually went to schools and universities to try and showcase some of the outputs from AM, where we try and highlight like innovation, problem-solving techniques, and more importantly, like sustainability. So we AM being able to make complex materials and create less waste, to try and highlight some of these advantages. So we go out and raise awareness about this technology. So that's another aspect of my role. So I'll then move on to like positive aspects, challenges, and opportunities in AM. Okay. So the first thing I would like to point out is there's that continuous growth in AM. We all know that the past year has been very challenging. And one thing with the AM sector was, despite the pandemic, there was still like a 7.5% growth to about about 13 billion pounds in 2020. So what this number tells you is that there's that continuous growth. And one of the reasons for this is there was that disruption in supply chain where you couldn't easily get goods from different countries. So people had to turn to their local like resources, like then which AM then became popular, where especially in the making of PPEs, masks, and things like that. So the key point from this slide is, although the growth was down, so in the previous 10 years there was that steady 27% increase, but despite the pandemic, it still grew to about $12.8 billion. So there's that continuous growth in this. And one of the other reasons for this growth is AM is being applied across different sectors. So from my screen, you can see, for example, I've only just selected a few because there are many sectors where AM is being applied towards. So you can see it's being applied to construction. A cool one, which I always like, is the food industry. You can now 3D print some pastries and bakeries, and aerospace and automotive sector. This is a sector that is utilizing AM strongly. And now, if you look at the bottom of the screen, you can see it's been applied in the health and biomedical sector. So I mentioned things about the PPE, especially because of the pandemic. We had to like print masks and face visors with 3D printing. So it's been applied across the health sector. And the main reason for this is that customization. You can actually make things that fit individual people. So that's one of the attractiveness of AM. So that's, and hence why it's continuously growing. So now let's go to AM and Industry 4.0. So a lot of you might have come across the fourth industrial revolution, where there's this new phase of industrial revolution where things are becoming more automated, more interconnected, and the aim for the output from this is to have like increased productivity and efficiency. And that's where AM comes in. So AM is one of these factors. So it's part of like AI, robotics, but 3D printing here is a major factor of Industry 4.0. And that's because you can create less waste, which makes it more efficient, customization, and you can create complex geometry. So key point from this slide, additive manufacturing is a core component of this new industrial revolution, which we're having now. Okay, so what are some of the things you can do with AM, with the knowledge of AM? So you can go from like being a designer or process engineer to things like more hands-on, like being an AM operator and technician, or even like me, where I'm like AM researcher and scientist, where people will develop and improve new AM materials, new processes. So this, as I've included there, this list is not exhaustive. There's a plethora of opportunities available that you can become with the knowledge of AM. Okay, so that's one of that. Now let's think about, so it's not all rosy, right? There are some challenges with AM, and I've said there's that fast pace and changing demands of AM. So one of the things that our researchers found is that shortage of skilled AM professionals with multidisciplinary and comprehensive skill set. So if you take a moment and think of these factors, so AM has different components. You can come from the design perspective, selecting suitable materials, and there are a series of different AM processes. You've got different equipment, and now you have to start thinking for when it's actually being produced, is it good enough? And after it's being used, what happens to the end of life processing? So thinking about, so there's that lack of skilled professionals that actually have that more to do. So that doesn't just have, for example, knowledge in car design, but can think of the best material or best process to use, and then think of what happens to the material or product afterwards. So that's one of the challenges we have. So if you have that understanding, if you can understand the relationship between these different factors, it will then even lead to greater innovation, optimization, and application of AM across different sectors. So additional challenges is standardization. Currently, I think there are working groups to try and improve this, but one of the reasons is because with different AM processes, it can affect the consistency and properties of the different materials and products. And this ties into like different machineries, different processing conditions, which then affect some of the properties of the AM materials and products. There's still the issue of cost. It's reducing over the years, but there's still that high initial cost of like AM machines and materials, and which over time becomes more economical, but at the start it's quite challenging. And the issue of time and speed. Currently, you can use AM, relatively speaking, might take a bit more time compared to things like extrusion or injection molding, but it's becoming faster and we're getting there. So it's improving, but these are still parts of challenges. So if you're sleeping, please, you can wake up now, and we're almost there. I just have one more slide to go on. So this is the time to wake up, because I'm just going to the final slide and top tips, okay? So my advice and top tips. So the first thing is, if you're a young person in AM looking to start working in AM, one of the first things I try to advise people is for starters, try and connect and follow, like for example, AM projects. You can follow people you look up to in the field and organizations. So for example, SAM, where that's an AM project where you can actually follow a lot of these organization or projects on social media. And what this does is it actually keeps you informed of different developments and opportunities in AM. With SAM, all of the opportunities, like for example, new courses that will come up where will be advertised on like the social media. So if you follow such channels or projects of people, you become aware of what's going on. Okay, be proactive and take opportunities. So for example, myself, I didn't start with a career in AM. I did make a mechanical engineering degree, but I've always been fascinated about improving materials and manufacturing processes. And here I've become an AM professional now. Another advice on top tip is think of those challenges discussed earlier. So things like the multidisciplinary skill set, about having that skill set of not just one aspect, but being able to relate it, be more comprehensive, and think of that and think of ways to solve or improve them. That will help. And one thing to also note is that there's that continuous growth and development of AM. So just because you've done a course now doesn't make you fully satisfied. You need to continuously learn, and professional development is key in AM because there will be new technologies, new developments, and you have to be open-minded, be open to creativity, and be prepared to adapt to different changes in AM, because that's what we've seen in the past few years in AM. And on that note, I'll end, and good luck to everyone that's joined us. And at the end, we'll be able to have questions at the end of this presentation. Thank you.
We thank you, Ade. Actually, I know that you're a smart guy, but I didn't know that you jumped directly to PhD after bachelor's degree. So that's awesome. Congrats.
Thank you very much. Thank you.
Yeah, okay. There are some, by the way, announcements on chat if you can look at it. One of them is our SAM project website. And also, I think Alessandra has posted another thing. Yeah, there's we have LinkedIn groups. One is the LinkedIn group of the project of SAM, and the other one is the LinkedIn group for job seekers, students, and other people who are looking for potential job posts or other things in LinkedIn. So you can join these groups to follow up what's going on, as Adam mentioned. So if you have some questions, you can either raise your hand and unmute yourself to ask the question, or you can write it on chat during the speech of the speaker or afterwards. Be sure that I will be taking care of your questions. Okay? So, do we have any questions to Ade at this moment? Well, if not, I would like to go to our second presenter. Our second guest is Anke Kaletsch from the Technical University of Aachen. Good morning, Anke.
Good morning.
Anke is the head of Powder Technology Institute for Materials Applications in Mechanical Engineering at Aachen University, and she's working heavily on additive manufacturing and hot isostatic pressing, where we run together several projects, and she has many published articles in her field of expertise. So, okay, Anke, the turn is yours. We would like to hear about your past background, so your current work, what you're working on regarding additive manufacturing. The floor is yours. Thank you.
Yeah, thank you very much, Kenan, for the nice introduction, and thank you very much for the invitation. It's a pleasure for me to share my experience today and to give you a little insight into what it means to work at a university in the field of additive manufacturing, how a career at a university in that field is possible. So I would like to start with my own background, with my professional development. Here we say that I have currently two positions at the same time. The first is the head of the division Powder Technology at the Institute for Materials Applications in Mechanical Engineering, and that is an institute of the university. And the second position is a deputy head of the Institute for Applied Powder Metallurgy and Ceramics, and that is an institute associated to the university. But both institutes are working very closely together, and they are doing the same research, and so both positions complement each other. As you can see, I'm in that positions around 6 years. That means I came into that positions directly after my PhD. In the time before, from 2010 to 2015, I worked as a research assistant also at the university in Aachen and did my PhD. And before that, I studied at the University of Applied Science in Aachen, mechanical engineering. And what you see is that either both my doctoral thesis and also my diploma thesis are not in the field of additive manufacturing. That means I stepped into additive manufacturing after my PhD. And yeah, what is the reason? Or was it easy? How was it possible? So as you see, during my PhD studies, and I worked in the field of brazing materials. That means a big focus of my work has always been in materials, and especially in the correlation of the microstructure of materials and the mechanical properties. So it was indeed easy to step into the field of additive manufacturing, because there the microstructure and the correlation of microstructure between microstructure and mechanical properties is a very important topic as well. And when you have the experience in materials, then additive manufacturing offers you a very interesting field of research, because you know, especially in the beam-based technologies, you get such interesting microstructures after the process. And when you understand the interaction between the process and the microstructure, you will be able to design microstructures and with that mechanical properties of materials. And that is what for me is very interesting in the field of additive manufacturing. That is one of the reasons why I stepped into that field, because I see so much potential in material development in that field. Another important point why I stepped into that field was that it is such a dynamic field, and I like the dynamic in that field. And as Adi already said, we have always some new developments on technologies, on materials for AM. And yeah, that is a very important and interesting point. What I forgot on this slide is that I worked as a student assistant during my studies. And if you plan a career at the university, or you plan to make a PhD, then I would really highly recommend to apply at some institute as a student assistant, because then you can demonstrate that you are doing good work, that you are interested in research, and I think that is the best possibility to get after that also a position as a PhD worker. Well, a little bit about my current position as a head of division powder technology. So in total, I have 10 scientific staff members working in 3 groups. So the working groups do not look like they have something to do with additive manufacturing, but additive manufacturing is a big part in all of our work. So we do not only work in the field of additive manufacturing, we also have other powder technological production routes, but additive manufacturing is really big focus. And yeah, what I'm doing the whole day, attracting third-party funding is a big topic, because the scientific staff members, they need to be financed, and that is mostly by research projects. My responsibility is to control the projects and all the orders within the division, the strategic development and promotion of the division. That is an important point, research strategy, because the field of additive manufacturing, it's so wide, there are so many technologies in that area, so you cannot do everything in the field of additive manufacturing. You need to focus on some technologies or to some materials or something else. And of course, then the build up of networks. That is, I think, always important. Also, also for a student or for a PhD worker, from the beginning to build up networks in the field of AM, going to maybe trade fairs. In Germany we have the Forum Next, and build connections and networks to other researchers in the field of AM. And besides all the other things, I'm working on my habilitation treatise in the field of my own main research. I have a research focus, and that is, as Canon already said, the combination of additive manufacturing and hot isostatic pressing. And maybe not all of you know what a habilitation is, because that is something very special in Germany. Habilitation is a postdoctoral lecturer qualification. That means it's the next qualification after the PhD, and in former times in Germany it was required to apply for a professorship. So nowadays it is no more required for a professorship, but it is of course very beneficial when you apply for a professorship, and that is also my I would say aim to have somewhere or someday a professorship in the field of additive manufacturing. Now I would like to speak a little bit more in general about what it means to work at a university. So when you plan a career at the university, that is mostly connected to scientific qualification. As I said, the PhD, for example, or after that, a postdoc, the postdoc period. So in Germany, it's a habilitation, but in other European or in countries all over the world, it could be a postdoctoral fellowship, or I think it's the same habilitation, it's the same level like assistant professor in other countries. So the main work is research. You will have your own research topic, and you will working on projects. Research projects, you need to publish your results in journal, you need to present your results, your research result at conferences, and you need to work together with partners from industry or from other universities, and with students, with student assistants, and you need to supervise bachelor and master theses. And for getting the research projects, we first need to apply for these fundings. That means we need to develop new ideas and topics for research projects, discuss these topics with other researchers, maybe presenting the ideas, and finally writing the research proposals. But it's not everything is public funding. So especially in the field of AM, we are very strongly connected to the industry, because the industry is very interested in the work we are doing at the universities on the research on additive manufacturing, because, as I said, it's such a dynamic field and we have always new developments. So the industry like to work very strongly connected to the universities, and so you need to write proposal quotations for industry, discussing topics. When you have projects, then you need to give updates in regular intervals, and writing reports. And a very big topic by working at the university is also academic teaching. So I would say every PhD worker and every postdoc is involved somehow in academic teaching. So the postdocs giving lectures, and the PhD workers, they are giving seminars and also practical training for the students. So in general, or as a conclusion, I would say working working at the university is very interesting because you can get a further scientific qualification. You have varied duties and responsibilities. You learn every day something new, but it means also a lot of reading and a lot of writing because you need to publish your results. You need to read the results of other researchers, but it will never be boring. That is something what is very important for me. So I like it that it is never boring at a university. So now I would like to show you a few examples in which field research in additive manufacturing is possible, and that is a little bit focused on the work, on the research we do here at our institute. We are focused on laser powder bed fusion technologies. That means melting in a powder bed and build up the geometry of the samples layer-wise by selectively melting material in a powder bed. And here you see, I call it the laser powder bed fusion process chain, what means from powder to component at the end, and the component has some mechanical properties, and the properties, they are a result of the microstructure, and the microstructure is a result of the combination of material and process. And process is not only the sample buildup, but also a post-treatment. For example, a lot of materials requires a heat treatment to achieve or to adjust the desired mechanical properties and the microstructure. And here you see so many aspects. When you change, for example, the material and the powder, it will have influence on the sample buildup, on the processability, as well as on the microstructure. And that means we have so much potential in that whole field to design materials, to adjust microstructures. And on the next two slides, I would like to show you a few examples on material development and also on process development. That means how a change in the material influences the processability and also the microstructure, and how a post-treatment by hot isostatic pressing influence also microstructure and mechanical properties, but can also complement the sample buildup process. And motivations for material development. What are the motivations for materials development in additive manufacturing? So we have some materials that are not very well suited for the process. That means materials that are difficult to manufacture, like very hard materials like tool steels or even high-speed steels. And you see, due to the process, due to the very high solidification rates and the high thermal gradients in the process, you get often samples like that. You see a lot of cracks, and we adapt the material, the chemical composition, to get a material that can be processed crack-free. And therefore we need to have a very close look into the microstructure to find the reason of cracking. In that case, it was, for example, the high tungsten content in the material, and the tungsten content forms here such strongly connected carbide networks, and across these networks the cracks were able to go through the material very fast and easily. So with thermodynamical or accompanied by thermodynamical simulation, we do here material adaptation. And a second motivation for material development is to increase the flexibility. What does that mean? Additive manufacturing is known to be very flexible concerning geometries, but it is very limited concerning materials, because we only have some standard powders And yeah, the range of these powders are limited. And to increase the flexibility in materials, we have an approach to work with powder mixtures. That means we mix standard powders to get new alloys. For that, you first need to define your property profiles. Here we see two property profiles, one in red and one in blue. And then we take standard powders and mix them in different compositions, accompanied by thermodynamical simulations to see what happens at the solidification state. And then we get different materials with different property profiles with the same standard powders, only by mixing them in different compositions. And now I see I'm already over the time, and this is my last slide, and that is about the combination of laser powder bed fusion and hot isostatic pressing. But maybe with a view to the time, I will skip that slide. I think you will get the slides after the webinar, and you can have a look and you can contact me for any questions, or we have the question and answering session later. And yeah, you can ask me.
Actually, Anke, we have time. I mean, just for 3 or 4 minutes, you can explain a little bit more about what this is.
Okay, that's perfect. Oh, thank you very much. On my clock, it is 2 minutes over time. Okay, perfect. So very short, HIP is hot isostatic pressing. That means it's a post-processing for materials, or it can be used as post-processing for materials that exhibit probably pores from the production process. For example, cast blades from aircraft turbines are HIP post-treated by standard. And you can also post-treat AM samples with porosity with hot isostatic pressing, and you can close the porosity with hot isostatic pressing. And that is the first motivation of that combination, because you can improve the mechanical properties, and especially the fatigue properties, because in fatigue these pores are defects and decrease the fatigue strength. And by having the possibility to reliable close porosity by hot isostatic pressing, maybe the relative density before the HIP process do not need to be 99.9%, because such a high quality requires a very long process time. And therefore therefore the second motivation for the process combination of LPBF and HIP is the acceleration of the LPBF process and the approaches to build samples with more porosity but faster, and then HIP them afterwards and have then fully dense samples after the HIP process. And you can increase the porosity with two different approaches. The first is the enlargement of the hatch distance. That means the distance between the single laser lines during build-up. And the second approach is just a single increase of the scanning speed. Both will result in more porosity, but both will also result in shorter building times. So you can save process time in the LPBF process. The only thing you need is a dense shell, because otherwise you cannot densify the samples in the HIP process. And that leads to the third approach, and that is that you only build the dense shell with additive manufacturing and fill in the powder afterwards. And then you can fill in the powder afterwards, then close the capsule, evacuate it, and put it in the hot isostatic press, and then you get the final component. And when you accompany that with finite element simulations, you can design the capsule of the shape of the capsule so that you get after HIP your desired geometry. So there are some simulation programs that are able to predict the shrinkage during HIP, and with that simulations, you can design the capsule before HIP to achieve the desired geometry. And you do not need to fill in the same powder like the capsule material is. You can also fill in another powder, and that offers the possibility to build the capsule out of a functional material. For example, a wear-resistant material or a corrosion-resistant material. And then you can let the capsule on the component after the HIP process, and the capsule can stay as a functional layer, as a functional coating on the component. So that means you print your coating in advance and fill in the component afterwards. Yeah, that were my examples and my experience in a career at the university. And if you have any questions, I would be happy to answer them.
Yes, definitely. We have, I think, 3 questions now. I see it on the chat screen, but I would prefer to go on with our next presentation. And then we have a long Q&A session where I will pose the questions from Antonio, Andre, and Meha to you, Anke, okay?
Okay, perfect.
So these questions are hanging on the Q&A. Let's just first finish our presentations, and then we will go on to our Q&A sessions with more deeply discussions. Okay, our third and last speaker is Aydın Yağmur from EOS company in Munich. And Aydın had a strong educational background, followed by various critical roles in different industries like aerospace and automotive. And his passion is to explore the mechanisms of laser material interaction, which was inspired during his study in metallurgical and materials engineering at Middle East Technical University in Turkey. Currently, he's working as an additive manufacturing consultant in EOS. So, hello, Aydın. We would like to hear your story and what you have been working on regarding additive manufacturing. So the floor is yours.
Thank you very much for the nice introduction and organizing this event. Hello, everyone in the audience. My name is Aydın Yağmur, and I would like to share my personal experience in my career, which has brought me to additive manufacturing, as Kenan mentioned. And I would like to share some highlights and at the same time some lowlights in my career. So I would like to start with a personal track. So I was born in south coast of Turkey in a city called Mersin, and I grown up there. Then I moved to Ankara, where I studied metallurgical and materials engineering in Middle East Technical University. Then you have 3 points here. I have industrial professional experience in different cities in Turkey, in different sectors like automotive, machinery, and finally aerospace sector, where I learned a little bit additive manufacturing. Then I decided to make a break to my professional career and came to Stuttgart, Germany, and I studied Master of Science in Material Science Institute there. And I also had a chance to write my master thesis in Max Planck Institute for Intelligent Systems, which was formerly the Institute for Material Research. And since 3.5 years, I live in Munich, in south of Germany, and work in Additive Minds Department of Electro-Optical Systems as a machine and solution provider in metal and polymer additive manufacturing sector. I would like to review a little bit my LinkedIn career first. So the site where you can see of the iceberg. So I had first Bachelor of Science in Middle East Technical University. Then I had 6 years of industrial experience. I had first 1 year of in an local automotive company. This was my first job in industry in Adapazarı in Turkey, and I learned about professional life, working with people, some people management, working with suppliers, different parties of automotive assembly. But then I decided that I would like to go with a more technical position, because I would like to learn a little bit more on the technical part and like to develop myself on this area. Then I changed to a Bosch plant in Turkey, which was producing hydraulic pumps. And I started working as a team leader of the materials laboratory in the plant. I learned a lot of experience. I had good experience with mechanical testing, chemical testing, microstructural characterization, and combining all this and making some decisions. And I was in the quality department, and I was in a position that to release raw material or heat treated parts to release them for the assembly line. So I learned that a lot of materials engineering experience. Then I changed to an aerospace company, which I learned a little bit, or which I got to know additive manufacturing there. I was working as a technology development engineer, and our department was focusing on scouting new technologies and implementing them in the production line. And we had a project, and we have found funding for our project, and we made supplier selection. So I don't say which supplier we select as a machine supplier, not to make advertisement, but then I decided to make a break in industrial career and would like to go on an academical degree, which was Master of Science. And I had 2 years of education again in Material Science Institute in Stuttgart. In the last 1 year, I have a chance to work in Max Planck Institute. As I have mentioned, my thesis was not directly related to additive manufacturing, although I would like to go on additive manufacturing during master years. It was on coupled germanium alloys, which is very exotic to find in the application area. But the main thing in my master education, I think, to apply advanced scientific methods to material science problems or material science phenomena. After that, I had a job offer from EOS in Munich as application development consultant, and I was focusing more on materials testing, qualification of materials for new applications, and consulting to our customers. Then I got a promotion, and now I'm an additive manufacturing consultant. This is a seniority level, so mainly the same job with some additional tasks and a higher seniority level. And in this position, I am again focusing on the materials process chamber, I would say. But for example, I have as a new task working on monitoring systems and training our customers, making projects together, trying to find solutions of their daily problems. So I would say working in AM makes really fun on the industry side also, not only for the university. And this is, let's say, my LinkedIn CV, and I would like to share here the portion of the iceberg, which is under the sea level. So you see here again another graduation and the timeline also. This is where my classmates graduated, and I had some additional months to graduate. So my graduation was not at my expected time. This was a low light. And then I started a Master of Science in my university directly. But after some months, I decided to quit, and I started job search. I searched a job, made some interviews, but couldn't achieve to find a position. So I quit job search and started my compulsory military service and have some months there. And then again, I have a job search area, which you cannot see on the LinkedIn. And then I found a job, worked 6 years, and then I started Master of Science in Stuttgart, and then again a job search period for 1 year, and afterwards I have my job and going on working in additive manufacturing. So the message I would like to give is every career, or most of the careers I have seen, there are some lowlights, there are challenging times. There are times that you don't know what to do, or you take some challenging decisions. And I think this is very normal, and this shows that you have a normal career path. Here you can see me working on the industrial 3D printer. I would like to give here some insights why I would like to go to a job every morning. Actually, it's not the case due to Corona situation. Generally, we work at home office and sometimes in the company. But what makes me motivated to work in the mornings until evening time? So it's the passion that I have against this technology, because additive manufacturing, first of all, helps people improve people's life. This is the application that I like most. For example, you can help people, or you can produce implants, some medical devices, so that people have improvement in their lives. They can recover, they can go on their life better than before. So this is the application. Medical applications are my favorite applications of additive manufacturing. Besides that, the technology is in the cutting edge, so it's completely new, and there are lots of questions that were not answered yet. You can try to find answers to these questions. This can be some internal company projects, or this can be some collaborations with the universities, as our previous speakers already mentioned. So it makes really fun to ask questions or try to find questions to find answers to the open questions. And one of the maybe hot topics of our society worldwide is also the sustainability. You know, we have a climate crisis, and I believe that additive manufacturing can help us to manufacture responsibly, so responsible manufacturing. For example, instead of producing to stocks and waiting until the stocks are melted down, you can produce just in time, or you can produce in a decentralized way, and you can avoid logistics and the carbon emissions. So I would like to maybe here summarize some key messages that I observed that helped me and other people to go on their careers, let's say, in a successful way. I would like to start with social and environmental impact. It always makes sense, and it is our responsibility to evaluate the social and the environmental impact of our jobs, what we do, and we should work in a way that we have positive impact on the other people's life and environmental conditions. Of course, ethics. We should always follow up ethic rules and try to be in a good ethical guideline, I would say. Whenever there is an open question, you can ask your seniors or your colleagues, other people, and take their opinions, and then you can make your own decision. One of the other important highlights, I would say, curiosity, asking why, challenging the standard applications, standard procedures, always brings new topics to you. You can learn and you can challenge your colleagues, your academic advisors, always ask why. And sometimes you get the question, we do it always this way, but this is not enough. Again, ask why, because at the timeline, somebody should make a decision, and you can learn the reason, and you can open up new areas for yourself. And one of the other topics is scientific methodology. For example, we are not academia, but during problem solving or our development processes, we also apply scientific methods. So I would like to mention that the importance of your academic education is very important, very high, because if you learn methodologies, you can maybe not directly, not in the same way exactly, but you can apply these scientific methodologies to your daily job. Of course, other topic, prioritization. There are many tasks in everybody's desk, and you should decide which one has the highest priority. Otherwise, you can work hard, you can have time, extra time, but at the end, especially for the industry, you should be a little bit result-oriented. which is another point. And I would say communication skills are also very important. If you look at the curriculum of many engineering or science programs worldwide, you see that there are limited number of social courses that the students have to take or can take. But for example, from my personal experience, although I work very deep technical topics, I would say the communication between different parties, like my colleagues, like industrial partners, customers, or universities, communication is very important. And I would like to mention that try to develop your communication skills. And one of the most important is also time management. I hope I am not over time. And I would like to thank you for your attendance. And if you want to reach out to me, feel free to write to me through LinkedIn. Thank you very much.
Thank you, Aydın. That was a nice presentation, especially your slides about the paths in a career is really meaningful, because I believe that there's no single career without ups and downs. So that's good to know for young people. I mean, no single career with always ups. There are always downs and ups, that's for sure. Okay, thank you very much for this nice presentation. So now it's, I think, time to go on the chat and start with our Q&A session. So we have several questions for Anke. I would like to start with them. So, okay, Anke, here's your first question from Antonio. He's asking, I'm sorry. Yeah, okay. Antonio is asking, he's saying that he's developing in his doctoral thesis many alloys such as tool steels, nickel superalloys, coppers, etc. And he is asking about the opportunities of collaboration with other research centers, universities, or industries.
Okay, so thank you for that question. I know a research group from Dresden, the Fraunhofer IFAM in Dresden, that is working on fused filament fabrication, and I think also the IFAM, Fraunhofer IFAM in Bremen. If you like, I can give you the contacts to make contact directly to research groups that are working on fused filament fabrication. So my research group is not working on in that field. We can have discussion about materials, because tool steels, nickel-based superalloys, these are materials we are also working with. So of course we can collaborate or discuss these topics of materials, but if you're looking for someone who where you can collaborate due to the process, then I would recommend the Fraunhofer IFAM in Dresden and in Bremen.
Exactly. I would say the same thing. As EPMA, we have many projects running together with Fraunhofer institutes. One is IFAM, both in Dresden, and the other branches in Bremen. They all work on additive manufacturing. There is also in Augsburg, Fraunhofer AGCV. That team is also active in additive manufacturing. So there are many places that you can look for some possibilities. Thank you. So the next question is from Andrei. He's asking that, do you think the material structure and chemistry knowledge is necessary or important for a career in AM?
I think there are a lot of fields in AM. When you focus on materials in additive manufacturing, then it is necessary, of course. But there are other possibilities. So not everyone who's working in AM is a material specialist. So I think as a mechanical engineer, you have everything you need to step into the field of additive manufacturing. I don't know your background, but in case of a mechanical engineering, when you study mechanical engineering, then you should have everything to step into the field of additive manufacturing. But if you're focusing really on materials development and materials in additive manufacturing, then I would say the material background is necessary, yes.
Okay, thank you. And he has a second question, but that's rather regarding the, maybe Aydın, you can answer this. The question says, which industries do you think more than others develop and implement AM in their production processes?
For the time being, I would say medical and aerospace sectors are the flag carrier sectors in additive manufacturing. But automotive is also stepping in, or if we think automotive has a little bit different condition because the high number of parts that should be produced. I would say in the coming years we will be seeing more automotive applications, and also an interesting area is also will be end users. For example, eyewear, glasses, glass frames. We are working also on this kind of topics.
Yeah,
Thank you. Yeah,
can I just add to the point for Andre when he or she said, do you think the material structure and chemistry knowledge is necessary? So there are different opportunities in AM, and for example, if you have an engineering background, like you said, I didn't have an AM background. I did the general engineering, and just with that knowledge and skill set, I've been able to apply, because always bear in mind that AM is just another way to make different materials. So if you have it, it's just then comparing and contrasting it, applying that principle to make a different type of material. So, and there are other opportunities, like, for example, AM supervisor, where you don't have to have that detailed knowledge of it. But I think if you have those different skill sets, it can set you apart, but it's not essential. But yeah, that's my contribution to that.
Thank you, Ade. I'm going on. The next question is from Meher. He or she, I think he, asks, did you, I think that question is to Anke. Did you have a special metal powder atomizer to produce these powders? I think it's hard to produce because of the higher melting point.
Yes, we have an atomizer, a gas atomizer, but our approach is to use powder mixtures. That means we mix it before the process, and we do in situ alloying within the process. So sometimes we develop new alloys and we atomize the new alloys, but our approach is to really use powder mixtures, because with that, in the end, you can also make multi-material additive manufacturing. And when you have, for example, machines with different nozzles, you can really mix the powders within the process, and that offers the opportunity of graded materials, for example. So yeah, we mix the powder in advance and put then the mixtures in the machine. And yes.
Yeah, thank you. So our next question is from Cenk. Actually, I think this is again regarding HIP, because it looks like HIP has been raising quite good interest, and that's something we already know. I mean, within the last current few years, to eliminate the problems of additively manufacturing parts just being like cast parts regarding strength properties, HIP seems to be a good solution, and it has already it's already been using in aerospace and other areas, as Anke mentioned. Okay, Cenk asks or says, everyone in AM mainly focuses on printing theory and application. However, there is a lack of knowledge and experts on post-processing operations and their relation to printing for the quality of the final part. I would like to take your opinions on that topic. Maybe one by one, you can say some things. Let's start with ladies first. Anke, what did you say?
Okay, I think in general, we see different approaches. So on the one hand, I know that some groups try to avoid totally the post-processing. They try to integrate the heat treatment, for example, in the LPBF process. That is also possible, because in case of tool steels or nickel-based superalloys, you have the quenching directly in the process due to the rapid cooling and the high thermal gradients. And then you have also a kind of annealing and aging because of the high temperatures in the layers beneath the melting area or the melt. So that is possible, but in my opinion, or I'm a friend of the other approach to make maybe the AM process in a lower quality and focus really on the post-processing. I think it depends on the application because, as I said, for some cases you need post-processing by hot isostatic pressing when you have high loaded components that are, for example, safety critical, like in aerospace. So there you need definitely HIP. And that means you can, you can build your samples in the AM process with less quality and save time. So I think it depends on the application, and both approaches, approaches are important. The first to totally avoid post-treatment and to integrate everything in the AM process, and the other approach to make the AM process with less quality and focus on post-treatment. I think both is important.
Yeah. Thank you. And Aydın, would you like to share some of your opinions regarding such post-processing methods?
Sure. Maybe I can add some insights from my experience. Maybe we can divide some post-treatments because some of post-treatments are for surface improvement, for example, roughness or surface condition. And the other ones, we can say heat treatments. HIP is, I think, some kind of, we can mention it as a heat treatment. That is true in some applications. Combining with HIP, you can increase the productivity. What good here is we started, or the AM community started with what is already improved in the industry. For example, mainly HIP cycles were being applied for the ones that were improved for castings. But nowadays, step by step, we are developing HIP cycles, HIP procedures, focusing on AM because we have different microstructure, different levels of porosity. So step by step, we are, or the community is integrating the post-processing, focusing on additive manufacturing. This is also a good area. For example, if anybody has a heat treatment experience in conventional industries, there is a need for this kind of experience for additive manufacturing also.
Yeah, thank you. So, okay, there's a nice question again for your work, Anke. I mean, that is something that should be asked. That's from Maximilian. He asks the economic point of view. How many hours of LPBF process outweighed the costs of a posterior HIP process? Yeah, that's a good question. How do you balance that?
Okay, we can accelerate, we can accelerate the LPBF process with that approach by 20 to 25%. But it depends on the geometry because we need to build a dense shell, and so the surface volume ratio is important. But in general, there are also some new papers in literature that say the total time saved in the LPBF process is around 20 to 25%.
Yes, let me say some words about this as an information to our audience. But actually, HIP is an old traditional method for near net shape forming in powder metallurgy, where you build a kind of canister, empty can, and you fill in the powder, and then you put it in a chamber of high pressure and temperature for a certain time to get a fine, solid, high-strength part. Okay, but nowadays, to improve, as I said, the quality of parts, especially for strength or hardness, let's say, in additive manufacturing, this method is used. What Anke works on is to combine these two methods, that you either print a kind of canister or you print rather a loose structure where you already have some powder left in, and then afterwards you hip. So this is a very new field, and this is really under focus of interest for many people. I would advise you to visit our website epma.com, where you will find the sectoral group of EuroHip with many ideas, projects, studies, especially our Congress. I think in our Congress in October, there will be really interesting presentations about hipping. So these are things that you can go on working, searching, learning. That can be a good step in your career, because it looks like an empty and a big road that you can run freely. Okay, now, yeah, are there any comments or things to add on? If not, I would like to ask a question that is rather the main question of today's meeting. That question comes from Mohammed. He says, my academic certification and research interest are in materials engineering. Can you please advise how I can develop a career in AM? Don't worry, Mohammed, none of us did have a career in AM. We all had either material science, mechanical science, even I am an electronics engineer, so you're not the only one. Maybe we start one by one. Let's say, Ade, what would you say for this?
Okay, yeah, I'll start on this, and yeah, I'll just reiterate your point as to yes, I personally never even had a background in AM. I did my degree was in engineering, mechanical engineering, and then my PhD was in composite materials. Before then, but so roughly materials and structures. But one of the things is one of the things I've said is AM is just another process of making materials and product out of many other processes. So I think having that background in material science, first of all, puts you in a very good position, because you already know how materials work, and applying those skill sets is essential to AM, is now trying to see how these same materials can be made with AM, and for example, see how you can improve on them. So this is coming from my background, and I think those fundamental principles, like for example, that you've gained from like materials testing, materials characterization, those skills are still needed in AM, because there's the issue of consistency and mechanical testing. So with every AM material, they are new and unique, so you still need to test it. So I strongly believe that those skill sets you've gotten from materials engineering are very much applicable. And in terms of accessing opportunities out there, I think it's just being able to highlight some of the skills you've gotten from it and showcasing it to potential. But like, it's about finding the right opportunity in AM. But I think your background puts you in a very good position. Yeah.
Thank you, Ade. And then let's go on with Anke, maybe.
Yeah, that is also my thoughts, because I think an academic certification and research interest in materials engineering is the best entrance card into additive manufacturing, because yeah, people who have a broad knowledge in materials are, I think, very necessary in additive manufacturing. And yeah.
Okay, and you, Aydin, what would you say?
Okay, I would like to start with an analogy. So there are many positions, for example, in the industry, and they rarely refer to your academical background. For example, process engineer, quality engineer, these are not academical titles. So it's like a Lego house, how you build your career, and you have very good skills. But what I have seen in the last 10 years, the borders between the positions and the academic backgrounds are going blur and blur and blur. Many people are changing disciplines, gaining new skills in different areas. So they are building their Lego house in a completely different way. What I would like to say, try to be open-minded, try to think out of the box. And what good nowadays is you have really lots of open sources to gain skills or learn a little bit. You can search for articles within this SAM project. Some trainings are already launched free for public. You can learn on this in LinkedIn. there are many professionals and academics that are open for questions. You can just write to us. I think at this form you can write to me. We can have some discussions. So there are options. And I think the main topic or the main advice or recommendation I can give is try to be open-minded. And in 5 years' time in your career, there will be lots of people who has good skills on material science. So try to enlarge your diversity in terms of skills.
Yeah, thank you. As all our speakers mentioned, there's no bachelor's degree study currently available for AM. All the work is going on master's degree or PhD degree, and these are all in the environment of mechanical engineering, let's say material science. So therefore, that's very good that you are in the field of material science. Plus, of course, some work together with computer-aided design and etc. Because AM is an interdisciplinary topic. Okay.
I would like to add one point. Sorry, Kenan.
I forgot you. I'm sorry. I forgot to. Yeah.
No. I just spoke, but I would like to add one point for Mohammed. I think important is when you know you would like to develop a career in AM, you should try very early to build networks in the field of AM. So currently it is difficult because there are no trade fairs, no conferences, but you can do this also in LinkedIn. I think LinkedIn is a very good possibility to build networks in the field of additive manufacturing because there are so many groups. You can start to discuss with people, and that is how you get to know that people and then to step into the field of additive manufacturing.
Yeah, okay, thank you. Now I will take our last questions from Alexandra, but before that I have a short announcement. It is important. There is an assessment survey, a kind of feedback survey that we would like you to take to improve the quality of seminars. If possible, Alexandra, please can you put the link on the chat? Of course, we will afterwards send this feedback survey link with an email, but if you can take it now just at the hot point, that would be fine. Therefore, Alexandra, if you can put the link, yeah, that's perfect. Thank you very much. Okay, now take our last question. Okay, what about the soft skills that you think are relevant to work with AM? That is team working, proactivity, adaptivity. So let's start maybe from who would like to answer first this question?
I think what is very important is communication skills, because the field is so dynamic and so wide, and you need to communicate with a lot of people, and I think communication skills are very important in that field, especially in that field, because yeah, as I said, it's so dynamic. There's every day something new, and you need to communicate with other people.
I think we made some surveys about this in SAM project, don't we? To create a profile besides the technical issues.
Sorry.
There's kind of work, yeah.
sorry, there was someone at the door. Yeah. Oh, indeed we did. And some of these soft skills or transversal skills are actually on. If you check the SAM's website, we've reported on some of this, and of which communication was key, and like interpersonal skills, because for example, yeah, AM is great, but sometimes we also need to be able to highlight some of the benefits and the challenges with it. So that's one of the things. And I would say more like also like research skills, just being able to identify what's out there and identify ways for improvement. So but for more of those skills, I would suggest actually looking at some of the deliverables on the SAM website.
Yeah.
Thank you.
So thank you. Aydın, would you like to add something regarding the soft skills that you need for AM?
Maybe under communication skills, I can say presentation skills is very much important, I would say, because everybody is very busy and you have limited time to express your position or your findings, and you collect feedback, and being efficient, giving the message in a clear way and getting the feedbacks in a structured way, I would say one of the key skills. And also, again, I would like to mention prioritization. Which task is the most important, which has the most influence, and which has to be done first? This kind of, let's say, decision and structured working is always needed in any kind of industry, not only in AM, I would say.
Thank you. I think we are done. That is the end of our webinar. So I would like to thank all our guests for their great contributions and enlightening us with their answers to the questions.
Oh, Kenan, you are mute.
I'm sorry. So I would like to thank all our guests for their great contributions and enlightening us with their answers to the questions. I hope that some followers now have a much broader vision about a career in AM, and I would like to thank everyone for listening to us. So as to stay updated on the development of the sector skills strategy and the AM world in general, you can follow the SAM project activities through its website, www.skillsforam.eu, Twitter, Facebook, and LinkedIn, as well as the AM Observatory as one-stop shop for all the latest news on the AM world that you can also reach from the project website. Okay. You can also join SAM project working groups that is already mentioned in the links. And also you can also, this is something different that I should mention. You can join the SAM project working groups as an associated partner or an expert. To do this, again, please visit the project website to get more information in the same manner. Okay. So our next seminar will soon be held with the subject of case studies and success stories in additive manufacturing, probably in June. Until then, we hope to see you. Back there again and as the SAM project team. And until then, we wish you have a great day. Thank you very much for listening.
Thank you. Have a nice day.
Thank you, Kenan. Thank you, everyone.
Thank you. Bye bye.
Thanks for everyone.
Bye.
Bye bye.